Here is a question you have never formally asked yourself. What does it actually feel like to die? The default assumption is simple: nothing, the end, a closed loop. This feels obvious. But this obviousness depends on a specific, fragile assumption about identity, that the self is a single, linear thread. When that thread is cut, the story ends. What if the thread doesn't break? What if death isn't a wall, but a branching path? When you die in one outcome, your consciousness simply continues in the branch where you survived. Every close call you have ever walked away from, you actually died. The you that survived is simply the one your awareness followed. This isn't a poetic idea. It is a direct implication of the many worlds interpretation in quantum mechanics. If it is true, dying is not a subjective experience. It is a transition you can never notice. The answer, if you follow it far enough, changes the meaning of every risk you have ever taken. It changes how you think about every decision you have ever made. You carry a model of death in your head without ever inspecting it. It goes like this: your life is a single line. At the end of that line, everything stops. No sights, no sounds, no awareness. The universe does not need you to keep watching. The many worlds interpretation of quantum mechanics does not just question that model, it shreds it. It says that at the smallest scale, every event with multiple possible outcomes actually produces all of them. When a particle faces a choice, the universe does not pick one path. It takes every path, each branching into its own full reality. This is not a metaphor. It is a literal interpretation of the mathematics, first formalized by Hugh Everett in 1957. Your life is not a single story. It is a tree with an infinite number of branches, and you are reading this on one of them. Now bring death into this picture. In a branch where you die, your subjective experience ends, but in branches where you survive, your experience continues uninterrupted. The crucial point is that you never experience the branch where you die. Your awareness only ever follows the branches where you survive. So from your own first-person perspective, death is never observed. You always wake up in a surviving branch. This turns death from an absolute end into a transition you can never feel. It is always the other versions of you that die. The you reading this right now has already been filtered countless times through every close call you have ever had. But what does this actually look like in practice? If we zoom in on a specific moment where death seems unavoidable, does the logic hold, or does it break down? That is what we need to examine next. Let's build the scenario. You are strapped into a chair. In front of you is a gun, its barrel aimed at your head. The trigger is connected to a device that measures the spin of a single electron. Electrons have two possible spin states: up or down. If the electron is spin up, the gun fires. If spin down, it does not. The measurement happens. The universe divides. In one branch, the spin is up, the gun fires, and that version of you dies instantly. In the other, the spin is down, the gun clicks harmlessly, and you survive. From the inside, you never observe the shot. In the branch where it fires, there is no observer left. Your awareness only continues along the branch where the gun misfired. So you always walk away. You could repeat the procedure 1,000 times. Each time, your consciousness tracks the path where the electron lands in the one state that keeps you alive. You will sit through 1,000 misfires without ever seeing a single shot. Now step outside the room. An external observer watches you run the trials. The electron's spin is random, 50% for up, 50% for down. On the first trial, there is a coin flip chance they see you fall. On the second trial, another coin flip. After 10 trials, the odds you are still alive from their perspective drop to less than 1 in 1,000. To them, you die early almost every time. Two sets of statistics, equally valid, describing the same events, and they completely disagree. This gap between internal and external reality forces a question that cannot be sidestepped. Who is the you that keeps surviving? In the branches where you die, did some version of you experience that death? If not, then what does it mean to call that person you at all? The thought experiment does not answer that. It only exposes the fault line beneath your feet. The quantum suicide scenario works only if branching is literal. But why would the universe split in the first place? That comes down to a 60-year-old debate about what actually happens when you measure a particle. Standard quantum mechanics says a particle like an electron can exist in multiple states at once, a superposition. But when you measure it, you only ever see one outcome. The Copenhagen interpretation says the superposition collapses into a single reality at the moment of measurement. Problem is, no one can explain where or how that collapse happens. Hugh Everett in 1957 proposed a cleaner solution: no collapse, ever. The mathematics describes all outcomes persisting, each unfolding into its own separate branch. The universe does not choose, it multiplies. At first, physicists rejected the idea because it seemed to violate conservation laws or common sense. But in the 1970s, they discovered a process called decoherence. When a quantum system interacts with its environment, the different states become entangled with trillions of particles. Those states can no longer interfere with each other. They behave as if they are independent realities. This is not a metaphor. Decoherence is a real physical process that is experimentally measured. It makes the branching automatic. How does consciousness fit in? You are a physical system. Your brain is made of particles. When you observe an outcome, your own particles entangle with one branch and not the other. You become part of that branch. Your awareness tracks that reality only. The other branch contains a version of you that made a different observation. Both are equally real. You just cannot feel the one you are not in. This picture removes collapse entirely. Everything that can happen does happen, and that turns the suicide experiment from a strange story into a direct consequence of the equations. Next, we will see what happens when you follow that consequence all the way. If many worlds is true, you have already died more times than there are stars. Every quantum event that could kill you created a branch where it did, but you never saw those deaths. You only remember the branches where you lived. That is not a loophole, it is the mechanism. Consider a single lethal quantum event. The universe splits. In one branch you die, in the other you live. Your consciousness only continues in the live branch. So from your perspective, the lethal outcome never happened. Now scale that up. Every heartbeat, every chemical reaction in your body involves quantum processes. Some could kill you in some branches, but you never perceive those endings. Your experience is a continuous string of survival branches, one after another. This creates a statistical gap that is hard to accept. Objectively, the probability that you survive a series of dangerous events drops towards zero. From the outside, you die quickly almost every time, but from the inside, you always walk away. Imagine a machine that kills you with 99.99% probability. An external observer sees you die on the first try. You, however, win the impossible lottery every time. Both statements are true. This is the probability problem of many worlds, and it is unresolved. But the internal perspective is the only one you have access to. So for you, survival is guaranteed, but this guarantee is not what it seems. The person who emerges from each branching event is not identical to the one who entered. You are replaced by a successor who shares your memories. After enough branches, the original you is gone. The continuous string of experience is real, but the subject at each point is different. That is the profound problem for personal identity that quantum immortality exposes. The self is not a single thing that persists. It is a lineage of replacements, each one inheriting the memories of the last. The person reading this sentence is not the same one who started the video. That person died billions of times already. You are the survivor, and that forces a question that cannot be closed. What happens to you when you split in two? Not as a metaphor. In the 1970s, philosopher Derek Parfit designed a machine that creates two exact copies of you. Every memory, every habit, every scar. You walk in and two people walk out. Both believe they are you. Both carry your full history. Your friends see two identical versions, so which one gets to call themselves you? Most people feel that neither truly is, or that both are, which is the same problem in different clothes. If neither is you, you stopped existing. If both are you, the word you no longer picks out a single thing. Parfit argued that this whole question rests on a mistake. Identity, the property of being the same person, is not what matters. What matters is psychological continuity. the chain of memories and personality that links one moment to the next. In normal life, that chain is unique, so we mistake it for identity, but in a split, the chain forks. Both forks have equal connection to the previous self. You survive in both, not as the same person, but as two separate continuations. Quantum branching does the same thing. Every split forks that chain. The version in branch A and the version in branch B both have equal claim to being the successor of the you that existed before the split. The self is not a single thread. It is a branching tree, and you can only feel one branch at a time. So the quantum immortality from earlier is not about you personally dodging death forever. It is about the tree never running out of branches that contain a successor of you. But the deep question remains open. Does the word you mean anything when there is no longer uniqueness? That is not a question physics answers. It is a question about what you think a self is, and that question does not close. There's a mathematical paradox hiding inside quantum immortality, and it makes the whole idea feel less like a superpower and more like a curse. The same branching that guarantees you survive every accident also guarantees you survive into the worst possible conditions. Consider a person with a disease that destroys the body but leaves the mind intact. In nearly every branch, the disease kills them, but in a tiny number of branches, they survive. They lie in a bed, fully conscious, in constant pain for months or years. Because only in that branch does consciousness continue, quantum immortality says that from the inside, they will find themselves in that bed. The universe does not select for comfort. It only selects for continuation. Aging works the same way. Your body slowly deteriorates. Your mind may fade. But as long as there is any physically possible outcome where you remain conscious, you will eventually experience that outcome. You could live to 150 with severe dementia, still aware, still suffering. The probability that you age gracefully becomes vanishingly small. Here is the mathematical paradox. In many worlds, every possible survival scenario exists, but there are many more ways to survive badly than to survive well. A huge proportion of survival branches involve pain, injury, or decay. Your subjective experience is overwhelmingly likely to end up in one of those branches. You are not unlucky. You are simply following the numbers. This is the quantum torment objection. It forces a distinction between surviving death and surviving suffering. Quantum immortality may guarantee the first, but it cannot guarantee the second. And the mathematical structure suggests the opposite. That if this interpretation is true, the future waiting for you is not an endless string of lucky escapes, but an endless string of agonizing survivals. The question then becomes, is that still living? Or is it a prison sentence that never ends? But the problems with quantum immortality don't stop at suffering. A stranger mathematical consequence waits. Imagine a game where each round you flip a coin. Heads you survive, tails you die. In many worlds both happen. After one round, half the branches contain a living copy of you. After 2 rounds, a quarter. After 10 rounds, fewer than 1 in 1,000. The fraction of branches where you still exist shrinks exponentially. Real life works the same way. Every moment carries tiny risks. For a constant annual mortality risk of 1%, after 1,000 years, the fraction of surviving branches is less than 1 in 20,000. After 10,000 years, it is effectively 0. Most branches end your existence at an ordinary time. Here is the paradox. Subjectively, you always find yourself in a branch where you survived, so from the inside, it feels like you never die. But from the outside, your continued existence becomes a statistical ghost. You are a vanishingly improbable fluke. Physicists call this a measure zero event in the multiverse. This splits your subjective experience from the objective structure of the branching tree. You feel immortal, but the world share containing you trends toward 0. The version of you that remains is increasingly unrepresentative. That forces a deep question about probability itself. If you are a random sample from all branches, you should expect to be in a typical one. Typical branches are short. So why would you ever expect to see extreme old age? Some philosophers argue that quantum immortality ignores probability, which is a fatal flaw. Others counter that many worlds does not allow probability to work that way at all. Branches cannot be treated as equally weighted when every outcome occurs, and the idea of a random sample collapses when nothing is left out. The debate is far from settled. So how do physicists and philosophers respond to this tension? That question leads directly into the next piece of the puzzle. Two camps, one says quantum immortality misuses probability and collapses. The other accepts the logic, but recoils from where it leads. Both must answer the same question. If you never experience death, what is it? In everyday thinking, death is a wall you hit. In many worlds, it is a branch you never travel. Your experience continues only on paths where survival is physically possible. The wall exists for everyone watching, but not for you. That swaps the object of fear. Not death, because you cannot experience nothing, but the survival state itself. The torment objection now dominates. The vast majority of branches where you persist involve pain, decay, or deterioration. Your subjective future is not a string of lucky escapes. It is a string of agonizing survivals. This changes how you approach risk. Take a dangerous action. In nearly all branches, you die instantly. In a tiny fraction, you survive injured. Since you will only find yourself in that fraction, the decision is not between life and death, but between different kinds of survival. Rational behavior shifts from avoiding death to avoiding survival that is worse than death. Cryonics and life extension take on a different meaning. They do not create new branches. They increase the likelihood that you land in a branch with revival or healthy aging. The goal becomes steering your path through the branch space toward tolerable outcomes, not cheating an end you never reach. Not everyone accepts this. Critics argue that without a working definition of probability in many worlds, the redefinition of death is a mathematical illusion. That debate is not settled, and the arguments on both sides lead directly into the deepest, unresolved questions of the framework. Alternative interpretations and scientific standing if quantum immortality can never be confirmed in any laboratory. Why does it appear in arguments from physicists like Sean Carroll? Because it is the direct output of an interpretation that might be the most honest reading of the mathematics we have. The standard Copenhagen interpretation says the wave function collapses into a single reality when measured. It works, but collapse has no equation. It is an extra piece invented to stop branching from being real. Many worlds removes that piece. No collapse, only branching. That is a trade with no empirical winner. Copenhagen buys a single world by adding a mystery. Many worlds buys a clean equation by multiplying worlds forever. Neither can be tested. Physicist Sean Carroll at Caltech argues that parsimony favors many worlds. The Schrödinger equation already predicts branching. Collapse predicts nothing independently and must be bolted on manually. Carroll also makes a sharp claim about identity. After branching, the copies become separate persons. They share history but not consciousness. The original self does not survive the split. Each successor is a stranger who remembers being you. Quantum immortality is not one continuous person living forever. It is a chain of distinct selves, each experiencing only a single survival. The fantasy of running forever along one thread dissolves. Other interpretations reject branching differently. Bohmian mechanics adds hidden particles to keep one world. Cubism treats the wave function as a tool for personal belief. All predict the same experimental numbers. All disagree on the underlying story. This leaves us with an open loop. The mathematics forces a choice between equally consistent narratives. Death, identity, survival, each shifts meaning depending on which interpretation you adopt. Physics alone cannot close the loop. The loop stays open because the question is not purely empirical. It is philosophical, and that is where the debate belongs. There is a contradiction you cannot resolve. Imagine a quantum coin flip. In Copenhagen, it lands heads or tails. In many worlds, both happen. A copy of you sees heads, another sees tails. Each believes they are the same person who flipped the coin. Each feels continuous with the past. But from the outside, there is no single survivor. There are two distinct people who both remember being you. That gap between feeling and structure is the unresolvable tension. You experience a single thread of consciousness heading toward one death. Yet the mathematics suggests there are many threads, each as real as yours. You never access the others, so your awareness stays linear. But that linearity might be a limitation of perspective, not a fundamental truth. No experiment can settle this. The interpretations predict identical results for any measurement. The difference lives only in the story you tell about what sits beneath the numbers. You can believe the other branches are physically real, making quantum immortality a direct output of the logic. Or you can see them as mathematical placeholders, meaning the entire argument rests on a mistake. Both positions are internally consistent. Neither can be falsified. This forces a choice that is not scientific but personal. You decide which framework makes the world coherent to you. Some embrace the conclusion and accept that they have already died in countless branches. Others reject the premise entirely. The evidence cannot help you. The tension cannot be broken by more data, so the loop stays open. The mathematics produces branching whether you believe in it or not. All you get to choose is whether those branches are real, and that brings us to the final question. So here is the final question. If you could choose, would you want to survive in a world where every near miss is real? Every slip on the ice, every car that swerves too close, every unexplained dizziness, those were the moments you died in another branch. Your survival here means another version of you did not. You are the one who made it through. But you are also the one who lives knowing that the only reason you are here is that the universe split. Would that knowledge feel like a gift or a sentence? Does it make you invincible or haunted? The physics cannot answer. The philosophy offers no verdict. The question is not about the universe. It is about you, and that is where it stays. No resolution, just the question.